Okay, this week, it's the last week in the 6-week cycle, okay? I'll be giving a retest. A retest will be given on the polar rectangular vector exam, which was the multiple choice test. You have Tuesday through Friday to come in and take a new test. Except for, I think, one period we didn't have a chance to go over the answers, but we'll make sure, I think it was second or third period, we'll make sure everyone has the answers, and if you want to come in and get tutoring on the things you didn't know, and you can take a retest, okay? It's up to you. Time to be accountable, okay? All right, exam. We're going to have an exam Friday over parametric equations and linear and angular velocity. That's what we'll be covering Tuesday through Thursday, linear and angular velocity, okay? Remember, parametric equations, you need to understand the problems of the Check Your Understanding assignment. That was when I finally came back, this assignment here, Check Your Understanding, okay? And we had the lion and the ranger, all right? Okay? So this is the problem. And the main, if you can get through 1A through G, that'd be excellent. This is really what, I'd love to see everyone be able to understand all of this, but if you have this understanding, you should be in good shape. Here's some of the highlights. Okay. You need to be able to write parametric equations. Here's the ranger on the wildlife preserve. He starts off at 100, his position minus 0.5 miles per minute. Notice, and he goes, his y, his x, his horizontal movement is x sub t, his vertical movement is y sub t. And it was 0.6 miles per minute. That's the ranger. Okay? Be able to write parametric equations. The variable is t. Both x and y use the same parameters. Okay? And remember, you can plug in t and get values for x and y and make a table, and you still have your coordinates x, y. All right, you need to be able to convert parametric equations. Okay, be able to convert parametric equations into y equals types functions, so y equals x, right? So here's an example of the ranger's y equals 0.6t, and we'll go this. So here I need to convert this whole parametric equation into y equals some form of x, okay? Get rid of the t, all right? So I take this y equals 0.6t, and we're going to solve for t. So if I divide both sides by 0.6, I get t equals y over 0.6. Now I have a value that I can substitute in for t. So I go back to the x equation, and 100 minus 0.5t is now 100 minus 0.5y over 0.6. Notice this ratio 0.5 over 0.6 is the same as 5 over 6. So I have basically x equals 100 minus 56y. Okay, that's what x equals. And now I want to solve for y. Notice, I don't like this denominator. We're going to multiply this entire equation by 6. So left and right side. I just do the whole equation. 6x, 600, and this 6, and then 6 times 5, 6. The 6's cancel out. I end up with 6x equals 600 minus 5y. Okay? And now all I have to do is, I'm going to move this over here with the x. So I've got the 6x minus 600, they're all together on the same side, and I've got minus 5y, and then I divide everything by minus 5y, and I get y equals negative 6/5 x. Negative over negative is a positive, 600 over 5 is 120, okay? So now I've got a linear equation. We can graph that if you want to put it in the calculator, okay? All right. Finally, last page, 4 minutes in the video. Be able to find the speed of the of the ranger, the lion, the ships, which is basically, the ships, the lions, whatever, they're on a magnitude, they're on a vector, perhaps, okay? And it was broken up parametrically into an x component and y component, just like we did with vectors, okay? Remember, the speed of the lion, the speed of the ranger is just the magnitude of the right triangle, okay? It's Pythagorean theorem. Okay, you need to be able to write an equation describing at any time t, the distance between 2 points. So remember the distance formula. Let's say the lion and the ranger are the lion's x2, y2, and the ranger's x1, y1. Okay, point 1. Just the distance between those points, the x2 minus x1 squared, and the difference in y squared. all under the square root gets me the distance of, let's say, the Lion and the Ranger, or the ship Andor and the Helsinki. All right. Well, how do we get each of these positions? How did I get x2? How did I get y2? How did I get x1? From those parametric equations. Okay. This is from the Helsinki. This is from the Andor. Remember, at any given time, we got x based on 900 minus 3t. And for y, for the Andor, the ship the Andor, it was just 2t. It was 0 plus 2t. Remember, initial position and the rate, the horizontal rate, initial position, vertical rate. For the Helsinki, its horizontal position, at any given time, its x-coordinate was 4t and its y-coordinate was 100 plus 2t. And we can simplify this, but we can come up with an equation. And we can also put this in the, we don't have to put it in the parametric mode, but f of x equals, and just use that for x, plug in x for t, where x equals your time, and your y-axis will equal the distance. And remember how we graphed it. It's kind of like an absolute value function. As we increase time, at some point, this was a minimum. This distance hit a minimum value here, okay? So we did that. Finally, figure out the time to a point or the intersection. And by that, also be able to find the intersection. Either parametrically graph your equation in parametric mode and trace, use the trace function, or convert it to, or convert this to, where am I? Y equals, and find the intersection on the calculator as well. But you need to be able to convert it to y equals if you're going to find intersection. Otherwise, you have to trace in parametric. All right. Remember, like with the Lion, we want to be able to, and the Ranger, time to a point or an intersection, okay? Well, we need a distance over rate will give me a time. Well, the Ranger, we're going to break down. We don't have to go on the hypotenuse. We can just go horizontally. What was the horizontal time to that point? Or maybe the vertical. So for this Ranger situation, he started out at 100 and traveled to the intersection where the x value was 45. That's 55 miles. And he had a rate of 0.5 miles per minute. Okay, this will come up top. The miles cancel out. 55 divided by 0.5 is 110 minutes. The Lion went from 0, the y-axis basically, to 45, to that x intersection of 45 miles. 45 distance over rate. 45 miles, that was the x of t of the Lion. Okay, distance over rate, 45 over 0.3 miles per minute gives me 150 minutes. So we're be able to do that, be able to figure out time to a point, and will the Lion and the Ranger meet up? And they won't. They're going to be there at different times. If this was the same time and they equal each other, so x of Lion equals the time of the Lion and the time horizontally for the Ranger equal each other, okay, they would probably be there. I would still double check the y then and check the y velocity, okay, and the y distance, and set that. Do the same thing for the vertical distance. But we know they're not going to be there at the same time, okay? All right. That's 8 minutes. That's a recap. I got one more video coming up for tomorrow, but this is something that you should be working on for next week, okay? All right, thank you. I've got another video coming up for tomorrow.